today we're talking about inverse trig functions. Remember that a trig function, remember that an inverse of a function is the undoing or the opposite of an original function, okay? Now, what we've been doing lately is evaluating trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, of angles to produce fractions or ratios. For example, what we've just been doing is problems such as the sine of 2 pi over 3. If I want to find the sine of 2 pi over 3, I know that I'm going to get some kind of fraction as an answer. Well, since 2 pi over 3 is in the second quadrant, I know my fraction will be negative. And then the sine of just pi over 3 is radical 3 over 2. So I know that the sine of 2 pi over 3 is just radical 3 over 2. Okay? Now, let's take a look at, try the next one, secant of 5 pi over 6. Well, again, now this is not an inverse, this is the reciprocal function. So I'm just going to think to myself, what is the cosine of 5 pi over 6? Again, because I'm in the second quadrant, cosine produces negative fractions in the second quadrant, and the cosine of pi over 6 is radical 3 over 2. Well, the reciprocal of that will be negative, and the reciprocal of radical 3 over 2 is 2 over radical 3, which when rationalized becomes negative 2 root 3 over 3. And then lastly, the cotangent of 7 pi over 4. Again, since that is a fourth quadrant angle, I know that cotangent produces negative fractions, tangent produces negative fractions in the fourth quadrant. And the tangent of pi over 4 is just 1. Well, the reciprocal of negative 1 is just negative 1. So the final answer is negative 1. Now again, folks, this is a review, what I've just done. Again, I'm given the sine of an angle, and my answer is some type of fraction. The secant of an angle is some type of fraction as an answer. The cotangent of an angle is some type of fraction as an answer. Well, does it make sense then, if I wanted to go backwards, instead of me being given an angle and being asked to find the related fraction, right? I'm going to have to now go backwards. I'm going to be given a fraction and be asked to find the related angle. All right? Now, let's take a look at what I'm talking about here. If I have the sine inverse of 1/2, well, again, sine inverse says go backwards. Notice, basically what I'm asking myself is, what angle has a sine of the fraction of 1/2 associated with its sine of that angle? Now, do not dismiss the positive or the negative of this. Well, this says, what angle or angles produce a sine of 1/2? Well, I know that sine produces positive fractions. This is a positive fraction in the first quadrant and in the second quadrant. The related angle that goes with the sine would be 1/2 would be pi over 6. So I know it could be pi over 6 in the first quadrant, but it could also be 5 pi over 6 in the second quadrant, right? So the sine inverse of 1/2 could be pi over 6 or 5 pi over 6. Now, I'm going to leave those answers as is for now, but I'm going to have to go back and address that later. The cosine inverse of a negative fraction, well, cosine produces negative fractions in the second and the third quadrant. So I know it's going to have to be a second or a third quadrant angle. Well, what angle has a cosine of radical 3 over 2? Well, again, that's pi over 6. Now, how do I put pi over 6 into the second quadrant? Well, that would become 5 pi over 6 in the second quadrant. How do I put pi over 6 into the third quadrant? Well, that becomes 7 pi over 6 in the third quadrant. And so the two angles that might produce a negative radical 3 over 2 for cosine would be 5 pi over 6 and 7 pi over 6. And then lastly, tangent inverse of 0. What angle has a tangent of 0? Well, if you think about the quadrantals, that's where that occurs. That'll occur at 0, at pi, and at 2 pi again, right? This one actually has 3 different angles that we could be considering. Now, that's no good. Let me tell you why it's no good. we remember that if you ever evaluate an expression, notice an expression, not an equation, you can only give one answer, right? So if I have these problems, I'm only allowed to give a single answer to the problem. In other words, in these problems that I just did, one of these guys will not count. We'll have to cross him out. One of these guys will have to be canceled out, and one of these three will have to be canceled out. Okay? Well, how are you going to figure out which one gets canceled out? Well, we have three rules. One for cosine inverse, one for sine inverse, one for tangent inverse. The same rules were for cosecant, secant, and cotangent inverse. So we're going to focus on the big three: cosine inverse, sine inverse, and tangent inverse. Well, here's the rules. If my original problem was a cosine inverse of a positive fraction, well, where does cosine produce positive fractions? In the first and the fourth quadrant, right? Well, since you can't give me both angles, one in the first quadrant, one in the fourth quadrant, we say we only give the first quadrant angle, okay? The first quadrant angle that would produce it, okay? If I see the cosine inverse of a negative fraction, where does cosine produce negative fractions? Well, in the second and in the third quadrant. So, again, if I have to choose just one angle that's associated with a negative fraction for cosine, I'm going to pick the second quadrant. So the moral of the story is, for cosine inverse, my answers must either be in the first quadrant or in the second quadrant for their angles. This range right here tells you that. All your answers must be somewhere between 0 and pi. They can't be less than 0, in other words, they can't be negative, and they can't be more than 1 pi. You better not give me any answers in that, okay? All right. So, well, with that in mind, let's go back to what we just said. Take a look at that first problem that we had. I'm a line who lies. I'll go back to that in a second. Take a look at sine inverse. For sine inverse, here are the rules. For sine inverse, if you see a positive fraction, you can give me the answer only in the first quadrant. If you see a negative fraction, you have to give me an answer in the fourth quadrant, right? So the third quadrant and the second quadrant will not be used for sine inverse, okay? Similarly, I could say that the fourth and the third would not be used for the cosine inverse, right? Lastly, tangent inverse. Well, again, tangent inverse produces positive fractions in the first quadrant and negative fractions in the fourth quadrant. So if you see a positive fraction, you'll give me a first quadrant answer. And if you see a negative fraction, you'll give me a fourth quadrant answer. But, and this is the part that's kind of a sticky point, you see these fourth quadrant answers? Well, would you agree that we've learned that the fourth quadrant is the same as the negative first quadrant? So what you have to do is, if you have a fourth quadrant answer, you have to change that into a negative first quadrant angle, okay? Even though technically they're the same angle because of the idea of coterminal angles, you have to do that, okay? So, lastly, before I go back to those other problems I was doing, again, for tangent inverse, you know that quadrants 2 and 3 cannot be given, right? All right, you need to study this. Now, going back. So, for sine inverse, what kind of fraction was this? Positive or negative? It was a positive fraction. Well, according to my rules, for sine inverse, if I see a positive fraction, I better give my answer in the first quadrant. Only the first quadrant answer. So, coming down here, which of these won't count? The 5 pi over 6. The pi over 6 is my first quadrant answer. That will count. Let's go to the cosine inverse. Cosine inverse, positive fractions, I'm allowed answers in the first quadrant. Negative fractions, I'm allowed answers in the second quadrant. Right? Well, if you take a look at this problem we just did here, what kind of fraction was that, positive or negative? It was a negative fraction. So according to my rule, for cosine inverse, if I see a negative fraction, I can only give the third quadrant angle. The second quadrant angle. So that means that I will have to cancel out the 7 pi over 6, and only 5 pi over 6 will be my answer. Now lastly, for tangent inverse of 0. Well, tangent inverse is between the first quadrant and the fourth quadrant. Now, here's the question. What angle do I choose? Well, it can't be the pi, because the pi is nowhere close to the first and the fourth quadrant. So going back to this, I know that for tangent inverse, the pi is not going to be the answer. So now we're down to 0 and 2 pi. Well, do you remember how I said you always have to give either the first quadrant or the negative first quadrant? Well, the reason is you always want to give an answer that is as close to the first quadrant as possible. Well, the first quadrant's here. Well, if I wanted to get to the fourth quadrant, I would have to go all the way to get to the fourth quadrant going this way. But if I went in a clockwise direction from the first quadrant, wouldn't that just be the negative first quadrant right there? So that would be the quickest way to get to this fourth quadrant, is actually going to the negative first quadrant. The moral of the story is, if you ever have to make a decision between an angle of 0 and 2 pi, you always want to use the smaller angle. So 0. Cancel out the 2 pi. Okay? All right. Let's do it again. Let's look at 3 more examples. I've got the sine inverse of radical 2 over 2. Well, what kind of fraction is this? Positive or negative? It's a positive fraction. Where does sine produce positive fractions? In the first quadrant. Okay? So I'm going to only give a first quadrant answer. What's the related angle that goes with radical 2 over 2? It's pi over 4. So my answer to this is simply pi over 4. And again, even though the second quadrant angle, 3 pi over 4, would produce the same fraction, I don't count him. All right, cosecant inverse. I've got cosecant inverse of negative 2 root 3 over 3. Well, now I'm going to have to combine a couple of ideas. Cosecant I'm not really comfortable working with, so I'm going to do the sine inverse. The sine inverse of, well, wait a minute. If I take the reciprocal of cosecant, I have to take the reciprocal of this fraction. But when you do the work on the side, you'd find out that would be the sine inverse of negative root 3 over 2. Well, where does sine produce negative fractions? In which quadrant? In the negative first quadrant. So, what's the reference angle that would give me radical 3 over 2? It's pi over 3. So I know my answer is pi over 3, but in the negative first quadrant, so the answer is negative pi over 3. Okay? Lastly, cosine inverse of negative 1. What angle has a cosine of negative 1? Well, wait a minute. That's a quadrantal angle. If you think about it, cosine inverse, or what, cosine of pi is negative 1. So the answer to this must be simply just pi. Okay? All right, that's how you take the inverse, evaluate an inverse trig expression. I'll talk to you Monday.